Hello everyone, welcome back to another episode of Students Teach Orgo. Today we are going to be covering the Wittig reaction. Let's begin. Alright, so this is for an unstabilized Wittig. So we'll cover what a stabilized Wittig is and an unstabilized, but we're going to start with unstabilized. Pretty much, this says that we can turn carbonyls into alkenes. We use something known as an ylide, a phosphorus ylide, right here. And by combining it with a carbonyl, such as an aldehyde or a ketone, we can create this coupling of carbon-carbon coupling reaction. Very useful because we can make a double bond where we need it and we can couple two groups directly. And this is our byproduct. We don't really care about this. This is just what byproduct is. Okay? So once again, we are using an ylide made of phosphorus, and we're combining that with this carbonyl to get this alkene. Very useful reaction. So, but when we mean unstabilized, we mean this ylide, there's nothing stabilizing it at all. Nothing stabilizing. And we'll show you what is stabilizing in the future. So what's the general mechanism? Well, this mechanism isn't really required in most courses, but we'll still go over it anyways. So the first thing is, so we said that this is an ylide. Ylide is basically any sort of molecule that exists. I mean, yeah, you could write that there's a double bond there, but in reality, most of the negative charge exists on this atom and positive charge exists on this atom. Okay, so you're going to be using the lone pair really on carbon number 4 to attack carbon 2, kick that up. You're going to form this sort of box right here. Basically, the oxygen is going to attack this phosphorus and form this box, and you're going to do what's called a reverse 2 plus 2 cycloaddition. So this bond is going to travel up, creating a double bond here. You can break this bond, and this bond is going to travel down, create a double bond here, and break this. Okay, so you basically are going to use electrons for those two bonds, create those double bonds. All right. So it's not that easy of a reaction to grasp immediately, but overall, you don't really need to go through the mechanism every time to do it. You just have to understand that we replaced this oxygen here. All we did was we replaced it with the methyl. All right, hopefully that makes sense. Let's continue. So how do I make these ylides, right? So once again, we said that they exist in resonance forms, right? And this attached carbon is extremely nucleophilic. How do we make this? Well, we can use alkyl halides. So let's use alkyl bromide here, react it with BPH3, and could create this sort of product here. So this is an SN2 reaction. And then the second part is just deprotonating. So you can use a base like butyllithium strong base, and it's just going to deprotonate. It's better to draw the deprotonation like this. Create that double bond. Okay. Unstabilized Wittig reaction. So there's two reactions where we don't stabilize this Wittig. So the first reaction, right, we are just going to react just perform the basic Wittig reaction. We have some sort of carbonyl. Right here, I attach it to a benzene ring to make it a little easier to see, and we just attach a BPH3 here. And let's say we had a ethyl group attached to it, to the ylide, right? So this is an ethyl. Well, we would form the Z product here. The Z product is formed. So this was part of our original carbonyl, and we attached this ethyl right here. So easy way to do this with I know it's a little might seem a little hard just by looking at it is you can line up your well, and one way to do it is actually you could just connect this, so eliminate this and then connect this double bond straight here, and you can get rid of this. That's always going to work. Just make sure that you get the right stereochem here, okay? And down here, once again, you could do the same thing. So except we form the E stereochemistry. Just because we use this base to stabilize it, we can form the E stereochemistry here. So this is going to be E. And all you do is, once again, eliminate this and then connect this to here. So we're going to form something like this. And you just need to make sure that you draw it in terms of E. Okay? All right, let's continue. So these are the stabilized Wittig reactions. So we were talking about the unstabilized, so this in the beginning, and no, we're talking about the stabilized Wittig reactions. All right. So when we talk about stabilized Wittig reactions, we mean that the elide is stabilized, not the carbonyl. The carbonyl does not need to be stabilized. We need to stabilize the elide. So here I am stabilizing the elide with this sort of highly oxygenated group, right, attached to the phosphorus, and then adjacent to it I have an ester. So this is called the HWE Wittig reaction, right? It's short for the scientists who created this reaction. But pretty much, well, this doesn't need to be an ester. I know I drew this as an ester. It could be a carbonyl or even a phenyl, right? But I just drew it as an ester to showcase here. We form the E as a majority. And once again, all you do is you take this carbon that we're here, and you're just going to attach it to this bond and destroy the oxygen. Okay? Not too bad overall. Might be a little weird at first just looking over the stereochem, but it's not too bad when you break it down into its constituents, okay? And in the still modification here, all we do is we use this fancy KHMDS reactant, and we instead we highly oxygenate again, but we use this fluorine groups. And this basically just stabilizes this negative charge a lot. And as a result, this is a very controlled way of forming the Z stereochemistry. So even though we can just form the Z stereochemistry in the regular elide, this is an even more controlled way to do so. And your professor might also test you on it. So it's very important to recognize it. All right. So hopefully that makes sense. Let's go into the practice problems. All right. First problem. So I recommend, how do I do this? Well, I would basically see which reaction is this. So we looked at 4 reactions. Which one is this? Is this a stabilized elide or an unstabilized elide? And then go from there. All right, move on. So this is a stabilized Wittig reaction where you have the elide that's stabilized and it forms the E stereochemistry. Okay, so all we do is once again, should be a negative charge here, but this negative charge is going to be attached here, destroy the oxygen, and you form this. All right. All I did was I flipped this ethyl group up, and just because I wanted to make E. Okay. All right. Hopefully that makes sense. Let's move on to the next problem. So here I want you to find out what is the intermediate that I'm going to get from this reaction. Once again, there should be a negative here. And then predict the final product after that intermediate as well. Okay, let's go over the answer. Well, how do I know what to do first? Well, okay. We start with this molecule here. This is known as a hemiacetal. Well, hemiacetals are actually in equilibrium with themselves in the open chain and then the ring form as well. So how do I break this apart? Well, if you remember from Marco's video, you can eliminate this bond, right? In only one way, it's easier to show it like this. So if I protonate this, use the lone pairs from this, I can push that there, push that there. So 1, 2, 3, 4, 5, 6. If this is my OH, this is going to be 1, 2, 3, 4, 5. This is 6. That's basically what I get. I could just deprotonate it at the end. Okay, this is going to be in equilibrium, but we are going to be using this molecule here. Why? Just because of this carbonyl group. So Wittig requires a carbonyl, right? That's one of the nice parts about this reaction is you need a carbonyl to react. So you need a carbonyl, which means you have to open up the ring. And then we're going to essentially do what I've shown before, where we have this elide here. You can basically eliminate the elide and then just form the connection between this carbon here. So all we're attaching on to the elide is this. Sorry. Okay, as I have it here. Okay, so please keep in mind, once we get to this intermediate, there's no E or Z here because these guys are equal. This methyl and this methyl, they're the same. Can't do E or Z. Okay? All right, but let's continue anyways. Then I'm going to apply PCC. So PCC is what type of agent? Reducing or oxidizing. What is it going to do? Well, if you guess oxidizing, you would be correct. So oxidizing because we are going to create a carbonyl here. So in this intermediate, we want to basically uh, create that carbonyl so we can, once again, this is very messy, but I think the gist still stands. We want to create this carbonyl here, and then we're going to react this. What type of reaction is this? Well, this is the still modification. The still modification is going to give us, what do you think? E or Z? Well, still forms Z, right? So we're going to form Z stereochem on our new site down here, which is exactly what I have shown below. And we are going to basically attach this group here. I'm going to form the double bond between this. Let's say if I enable this alpha, for alpha and beta, that's where I form my bond. Okay? So this is beta, and this is alpha. It's a little tricky to see that, but you could think of the double bond replacing, basically you just eliminate the O and attach it directly to this. That's another way to think about it. Just double bond it directly to that beta. Whatever way works for you, as long as you get it right. Okay, let's do practice problem 3. So think of a way to synthesize the following compound. So think of where do we start? So we're given where we start, and we're given where we end, but think about what steps do I have to take in between. Hint, it's going to involve Wittig. All right. So we only have to do one Wittig here. The only thing is we need to protect our carbonyl on the actual compound. This compound here, just because it's going to self-react otherwise. So we protect our carbonyl, and we are going to use phenyllithium. Now, why do you think we're going to use phenyllithium? Well, we want to create the E. And this is creating the E right here. So this is going to be E isomerism. And then we just use H plus to remove our protecting acetal. Okay, hopefully that makes sense. All right. All right, let's do practice problem number 4. So I want you to synthesize the following compound using reagents or reactants that have 4 carbons or less. I'd like to count the phenyl ring as 1 carbon just for simplicity's sake. Take a minute to do this. Okay. Before I even show you the answer, starting here is probably going to be the most difficult part. The question is, where do I start first? Well, in Wittig reactions, if you ever see a double bond that's like a lone double bond existing in the middle of a molecule, like this one right here, right? That screams Wittig, okay? Even if you're like doing an exam and there's a lot of other reactions and you see that double bond, that screams Wittig. All right, not always going to be Wittig, but I think a lot of time it can be. All right, so what you do is you cut this bond, okay? You cut this bond. Somewhere you're going to put the carbonyl. Somewhere you're going to put the elide. Where do you think is going to go? Where do you think what's going to go where? Now, in this case, it doesn't really matter too much which way you go. So I decided that you could put the elide on this carbon and the carbonyl on this carbon. All right, so and then that gives you a kind of an idea of where to start from. So we're going to start from this compound and then move forward. But there are other ways you could start from the other compound and move forward. Up to you which way you want to go. This is just the route that we chose. All right, let's continue. So to craft this, so on the other page I was showing, okay, so I was showing this molecule. In reality, we can't have this molecule exist just because of this carbonyl, and we need to protect it. So the only way to protect the carbonyl is to use an acetal. So this needs to be removed, and this needs to be turned into an acetal. And I think this is the point at which you know, okay, I need to start from here. So I need to make this compound. But even then, like, okay, if I start here, I see that I have 1, 2, 3, 4, 5, 6 carbons. So I need to go back even one more step where I need to eliminate the ylide and I need to start with bromine. That's generally my thought process here. So I know it gets a little messy there, so let's start from the beginning. Once more. You see this double bond. Okay, great. Break the double bond. On one side, put carbonyl. The other side, put the ylide. Well, how do I make this? Well, I can't start with this. It's going to react with itself. So I need to create an acetal here. So if I remove this, create an acetal to protect this carbonyl. Can't start there either. So in reality, I need to start even going more back, where this is a carbonyl. We're going to eliminate this guy. This is a carbonyl, and this is going to be an alkyl group. You remember how we talked about synthesizing and ylide. So in reality, this is going to be our starting reactant. It's exactly what I have here. Starting reactant. Okay, so starting from here, we then apply our protecting group. Then this is how I made an ylide. So first we used the SN2 attack, and then we used butyl lithium to deprotonate to create that double bond. Then we attached the phenolithium here to get this E configuration. And then all I did was Jones at the end. So H plus to remove the protecting group, and then Jones at the very, very end to get that carboxylic acid. So it's kind of a intensive synthesis, but if you break it down into starting with that double bond, I think you can get an idea of where to go from next. You just need to make sure that you have compatible functional groups on the same molecule, because if you have incompatible functional groups on the same molecule, then your reaction simply won't work. All right, let's go to practice problem number 5. So predict the following product. Here I have a double Wittig reaction, so think about how that's going to work out. Let's move on. Well, so the first reaction, what type of reaction is that? So we have a stabilized Wittig, right? But it's not a still modification. It's just a standard HWE. So if this is my HWE, HWE always forms E. So I'm going to form this E intermediate down here. All I'm going to do once again is I'm going to attach this carbon here, move this, and create the double bond to whatever alpha, and then etc. Okay? Not too bad. Okay? That's exactly what I have here. Next, I'm going to use H plus to remove my protecting group. So I'm going to get my carbonyl back. And then I'm going to do one more Wittig. This is just an unstabilized Wittig, so I form Z. And I just attach, basically, if this is A, attach A here, attach just a single ethyl. Sorry, single methyl group. This is A. Okay. This is our final product. So this configuration here is Z, and this configuration here is E. This is a great way, Wittig in general is a great way to have molecules with specific stereochemistry. And you can imagine how important that is in fields like pharmaceuticals, right? Where you need a certain drug that binds in certain types of configurations. All right, well, hopefully this makes sense, and we'll see you in the next video. Thank you.